This video is supposed to be helping you for Newton force practice from. So for this activity, you're gonna have to show all your work. And you're gonna have to show all your work like I do, step by steps, because we have to follow the grading rubric. So the video, I'm not gonna put in any values or any number. This video is supposed to be your template to help you solve certain types of problem only. So this type of problem, as you can see, there is an object resting on the floor, and you see the coefficient, which means there is a friction, and there is a force that is being pulled at an angle. So it can be different angle, it can be different coefficient. So for this one, let me refer back to question number 1. So question number 1 in the friction practice problem. So what it says is that a 15 kilograms box is being pulled along level ground by a 75 Newton force. So if this being the case, you're going to have to analyze what the question is telling you and put the value in. So the force is being directed, is being pulled at an angle 20 degree above the horizontal, as you can see over there. And the coefficient of the kinetic friction is 0.33 because the box is moving. And what is the acceleration of the box? So this is no longer a static equilibrium position because the force is being applied to the object at a certain angle. So first, I'm just gonna go ahead by drawing what from the question. This is what I got out of force being pulled at a certain angle from the horizontal, and it is mu, which is the coefficient, which is the friction, and the formula for friction is equal to coefficient times normal force. So let's talk about what is normal force. Okay. The normal force only occurs when an object is sitting on a surface. If there's no surface, there's no normal force. Common sense. Okay, now I'm gonna go ahead and draw a free body diagram and it onto this one. So I'm just gonna go ahead and draw the force in the y direction first. So I'm drawing first, which is mg, which is the weight of the force due to the gravity. That's the first thing you need to be drawing, is the force due to the gravity. And then also, for the third law of Newton, the normal force is the force of the floor exerted on an object, which is in this case, which is equal to the weight. And also, the force by itself as an angle. So I'm gonna have to break into two different components. So this one would be forced cosine angle. In the y direction, that would also be the force sine angle, depending on what angle it is. So now that we have three different forces in the y direction, and we're gonna have two different forces in the x directions. So just to sum up about what we've learned from this free body diagram, how many forces are acting upon the object in general, x and y direction combined. So that would be force in the y direction and force in the x direction, and also weight, normal forces, and the friction, because the object is being pulled that way. So just to contradict what I've said earlier, that the normal force is equal to the mg, but not in this case. And I'm just gonna go ahead and show you how it's done in just a minute. So go ahead, let me go ahead and prove it to you. Sigma Fy equal to 0. So how many forces in the y directions? 3. Up, down. So I'm just gonna go ahead and draw that again. N plus F sine theta minus mg is equal to 0. If I were to calculate for normal force, so what I would do in this case, it would be normal force is equal to, you know, when I add this one mg, it will become mg over here on that side, plus, so I have to get rid of this one, so I will have to subtract F sine theta. So this one I will have F sine theta. And that's your normal force. You're gonna need this normal force in order for you to calculate the force in the x direction. So, any questions so far from this one? We have to have these formulas in order for us to get points. So now the question is telling us to calculate acceleration. So I'm gonna have to go ahead and go back to the x. So fx is equal to mg, ma. Because the object is moving to the right direction. So we're gonna have to consider how many fx do we have. We have 2 fx. So we're gonna write the first force first, which is F cosine theta minus frictional force is equal to ma. Now I'm just gonna go ahead, you know, I copy this down, I bring it down. So the formula force for the friction is mu n. So I'm writing down mu, and I know what my n is. In this case is mg minus F sine theta. Is equal to mass times acceleration. If you were to calculate for the accelerations, so I would do this one right here. So now I will determine that. To calculate the acceleration, we would just go ahead and substitute this value in. So it's like we want to see, and that will give you the values of the acceleration of this block when the box is being pulled at an angle of 20 degrees. So I'm going to go ahead and talk about question number 2. Then they kind of ask you to calculate for the acceleration. So I'm going to go ahead and first draw a diagram. So now instead of being pulled or being dragged at an angle, so she's actually sliding out at the angle. So we're going to go ahead and have to draw what the angle is and label out the angle. So basically I have the angle, and she is an object, so I'm going to draw her on top of the surface right here. And I'm also going to go ahead and draw, okay, let's look at the questions. So it says a person who has a mass of 45 kilograms starts sliding down a slide that is inclined at an angle of 45 degrees Celsius. If the coefficient of kinetic friction is that, so which means we also have mu k is equal to something. So when you have mu k, you also know that it involves frictions. So the friction is equal to mu k n. That's one of the first things you need to know, that there's a friction and there's a formula for friction. So now I'm going to go ahead and derive how we get in from this system. This system is a little bit difficult because it involves more forces. So first, an object has a mass, so I'm just gonna write down mg, and it involves the incline. So I'm gonna go ahead and draw it's the same thing too. So at the angle right here, so that would be mg cosine. And there is a normal force acting upon this object because it's sliding down on the surface. Normal forces. Okay, that's it. And then what it says is that an object is sliding down this way, and there is a friction going the opposite direction. So I'm gonna go ahead and draw the friction that way. And you also have the weight component in the x direction. This is mg sine theta. So basically, do we complete all the free body diagram already? Let's think about it. The weight, we have the weight because those are the forces that are actually pulling the object down due to gravity. I have weight in the y direction and weight in the x direction, and I also have the frictional force which is slowing the objects down. And I also have normal force which is acting upon the surface. So basically I have all the forces that I need. So I'm gonna go ahead and figure out the normal forces by looking only sigma y equal to 0, because the object itself is not being lifted up from surface, which is at equilibrium position. So I'm gonna go ahead and write that down, which is n, remember up minus down. Cosine angle is equal to 0. And the n would be in this case. I'm trying to get rid of this by adding mg cosine theta on both sides of the equation, and that would give me mg cosine theta. That's what I need for my normal force in order for me to calculate the acceleration in the x direction. So now let's go back to same thing. Calculate acceleration, right? So I'm gonna go ahead to take consideration only x direction, and it has a force in the x direction. Basically, it is sum of the forces in the x direction is equal to the mass times accelerations. So the acceleration depends on the force and the mass, and that's what you need to get out of. So let's look at the acceleration. How many forces do I have? Mg sine that. Okay. So for this one, I'm gonna say that since this weight has more force than the frictional force that is slowing it down, so I'm gonna write down as mg sine theta minus fx is equal to ma. The frictional force also bring it down because it is the same thing. I'm not doing anything to yet with the calculation. I substitute the formula for the frictional force, which is mu k, which is given for you, and the n in this case is mg cosine theta is equal to mass times accelerations. So from there, I'm just gonna go ahead and figure out how to calculate the acceleration by dividing cell by mass on both sides of the equation. So the formula for my acceleration would be equal to mg sine minus mu k mg cosine theta divided by mass. That would give you acceleration in the x direction. At this point, I want you guys to go ahead and at least try to attempt to apply what you've learned from this video and use the values or the number given from the equations to plug in the number to see what answer you will come up with, and discuss this as a class.